In this section, what we're going to be doing, section 5, 10, which more or less can be just summed as the closure axioms. Okay. The reason this idea is a little bit more abstract than maybe some of the things you've done in the past, but it's an important concept to understand as far as math goes in the future, especially if you're going to have a future here at MSSM. Whenever you talk about closure, you need to talk about an operation and a set of numbers. So the book that I'm using mostly just talks about closure over the real numbers. So they consider the real numbers. This is a symbol, by the way, that we're going to use to denote the real numbers in case we ever need to. So if we're going to talk about closure under multiplication, what are we going to talk about? So the closure under the multiplication is going to say if x, y are real numbers, okay, so this says if x and y are real numbers, then x, y is a unique real number. And if we wanted to talk about closure under addition, then we would say if x and y are real numbers, then x plus y is a unique real number. So what do we mean when we say unique? What we mean is that there is that it's one number and only one number. So x plus y with designated x's and y's, like a single value when you substitute values into them, is only going to result in one possible solution. So you can't have two inputs with two different outputs, for example. So the way you got to think about this is you're dealing with the operation. Here you're dealing with multiplication, and here you're dealing with addition. And what it's saying is closure happens if you take a set of numbers and you then put two of the numbers from that set into that operation, and it spits out another number that also is in the set, and it can only split out one unique number for that set, then that the operation and the set is considered closed. Okay, so let's get some more practice with that, just because it's a little more in depth than that. So if you just consider a set of numbers, how about -1, 0, and 1? And if these are set symbols, which is set notation. So this is a -1, 0, and 1. So if we want to think about, say, addition, okay, so is this set, let's call this set S, okay, is set S closed under addition? So what do you have to ask yourself? Well, what you need to do is you look at every single one of the elements in this set. So, and you want to be able to add any two of them. So what happens if you add -1 to -1? Well, the answer would be 2, right? So -1 plus -1 gives you -2. Is -2 in this set? No. So it's not closed. Okay, what about multiplication? If you look at multiplication and these numbers, you have to say, okay, if I take any two of these numbers, can they be multiplied together? Well, what's -1 times -1? Well, that gives you 1, which happens to be in the set. Okay, what about 0 times -1? Oh, that gives you 0, which is in the set. And actually, if you look and you do every single combination of these three numbers with multiplication, you're going to find that they only multiplied to other numbers in the set. So multiplication is closed on set R. Okay, so you talk about operations and you talk about the set of numbers, and that can tell you whether or not an operation is closed or not. So from there you can look at anything. So you remember back, I believe it was chapter 1, you dealt with some set of numbers, and if you talk about the integers, okay, this is going to be my designation for integers. So if we want to talk about integers, are they closed under addition? Well, what do you think? If you take any number or its additive inverse, and you add another number and or its additive inverse, are you going to get another integer? Yes. It's hard because we're not actually proving whether or not these are true, but to prove that something is not closed, all you need to do is find a counterexample. So back up here when we looked at one number that wasn't true, we found a counterexample and we could say it's not true. To be true, it takes a lot more work to necessarily prove that, but in this case you're going to just like think it through, and if it makes sense then you can say yes. So yes with addition. What about subtraction? If you take any integer and you subtract it with another integer, are you going to get an integer? The answer is yes, so that means it's closed. What about multiplication? You take any integer and multiply it by another integer, are you going to get another integer? The answer would be yes with that. And finally, what about division? What happens if you take an integer and you divide it by another integer? And here's where we're going to hit a problem. So if you take something like 2 divided by 3. These are both integers, and you're using the division, right? But is this 2 divided by 3 an integer? No. So it's not closed. And that's pretty much the format that you should use when you're looking at whether or not you think something's closed or not, and the thought process you need to go through. You should pick an operation over the set and think about any number from that set. If you use that operation on it, is the result going to give you a unique solution that also lies in your starting set? And that's closure.